valmis, se on muuten.
On sitten All right, welcome everybody to our February meetup. So for all the new people, I'm Timo Studel, one of the organizers here, and together with me here is Niko Kivelä, who is one of the organizers as well. We have a much bigger team, but we have been the ones active recently. Actually, just because we have the bubbles today, I realized to send a message to the founder of this group, Erno Aapa, that if he can join us today, but looks like he couldn't. And well, now coming to the thing that why we have the bubbles today. Well, we have just got our 3,000th member of the group. And that's why we are celebrating here. So first of all, so let's have a... Okay. Is it better? This mic needs to be used next to my... Okay. 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 Is it now better? Yeah, I can think so. Because I can hear my own voice. Yeah, well, the echo doesn't disappear. All right, but hey, yeah, the bubbles today are for our, how should you say it in English, 3,000th member, 3,000 jäsen. And so first of all, so let's announce, so our member, the 3,000th member was...
Hey, not going to tell it yet. Yeah, so I'm Niko. Timo asked me to do this certificate because apparently our company is the only one in Finland who has this technology called laminointikone. And the name was written in some ancient font as well. So when I did this, I checked that what does it say? And I noticed that it's actually a guy from my team. So congratulations, Taneli Kähkölä.
And second reason to celebrate today is that kind of the goal I have been announcing quite a few times already is that we should be again the biggest group in Finland. Well, just today we are 5 members bigger than AWS group. So that's also worth of celebration. The thing is that I can say that we are now the biggest professional group in Finland. A few years ago, this tracking of this was easier because you could see from meetup.com meetup groups for certain areas sorted by the size, but you can't do it anymore. But then I figured out that there was some group that had like 20 members more than us, which is called Meetti. So it's a kind of a more like kind of some random stuff, and it's kind of hard to compete when we have a kind of a really focused group with that kind of a stuff. But let's see, we were only 20 members behind. But let's say that I'll stop more or less here. The only thing I want to say here is that, okay, if we want to continue this track of having monthly DevOps Finland meetups, we are missing a host for March. And it could be a new one, it could be an old one. Like I think that some companies that come to my mind straight away, I have been in some meetup at Nordea. So if there's somebody who has good contacts there, and Zalando has been arranging lots of meetups. But anyway, I mean, if any company you know that could be available, I think we have 2 speakers already, like for our standard set. So the third one will always come from the host, if the host wants to have that, and that's how it goes. Today, exceptionally, we have 4 talks. Luckily, they are not that long ones, all of them, so we are back to bed in time. But I hope you enjoy, and thank you.
Okay, thank you.
And now the bubbles.
Bubbles. Yes, so my name is Pasiniemi, and I'm from the host Nitor, and I won't bore you too much with the company
presentation or anything like that. We're a consulting company. I lead our support and maintenance division, and we're hiring, obviously. So if you'd like to hang out here every night, then come talk to me. And Lappis there is also our one of our recruiters. So if you want to know more about what we do and how we do it, I'm here for that, and Lappis is here for that. And obviously, Pekka is one of my guys, Kalle is one of my guys, so they also know how we... yes, owned. And Pekka will be talking next, actually. About going to bed, the sauna is going to be warm. Cleanup starts at midnight, so before that I need to kick everybody out, but until then, please feel free to hang out and use the sauna and have beverages. There's beers in the fridge. There was all of the other drinks are on the table, and sandwiches are still available, I believe. So welcome. Let's have a good meeting. Thank you.
Pekka, on stage.
Yes. Kuuleeko Pasila? En Pasia tarkoittanut vaan. Kuuluuko se sinne? Kuuluuko tänne hyvin? Oletetaan, että kuuluu. All right. So hello, I'm Pekka. I work here at Nitor, specifically Nitor Care. Pasi is my boss. He owns me 8 hours a day during the week. Not all days, but I've done a couple of AWS disaster recovery simulations, and that's what I'm going to talk about here. Some personal background first. I've been me since 1981. I don't know what I was before that. I've done half and half dev/support, so jack of all trades, master of none. And today I got to hate PowerPoint, for example. I've been working with OpenStack a little. If you don't know what OpenStack is, I don't know either, but I'm going to cheat. OpenStack was software to run private cloud computing that tries to be compatible with AWS interfaces. So that's what it was. I don't know what it's today. Probably something like that. So I'm quite familiar with cloud infrastructure, like not the thing you use when you are using a public cloud to build, but what's behind that. But Nitor Care is the first place where I actually work with public cloud more. And listener beware, these are my opinions. Yada yada yada. So what are we going to talk about today is, well, what I'm going to talk about. If you haven't saved your changes to long-term storage and somebody turns off the electricity, then your changes will be lost. I don't know my audience really, so I'm going very general and sort of like trying to start from the ground up. What is disaster recovery? Is whatever you are doing, sometimes unexpected trouble happens. And you can make recovering from the trouble easier by making the unexpected expected, and planning for those things that might happen. And you can formalize this thing in a document called a disaster recovery plan. And well, that's already good that you do that. But then it's good to actually test the plan with what I call a simulation here. And then you can take the results from that simulation and use it to refine this disaster recovery plan. So what's in a disaster recovery plan? It defines the system and looks at the risks that the system has. So we look at the infrastructure. We think about what the applications we are running on that infrastructure. We are thinking about what the users are doing with the applications. How are those applications developed? How is it operated, maintained, etc., etc. So this is sort of like the system, and then we think about what are the risks
for the system. So an operator never done an error with the system, right? So this is sort of like the high-level thinking in the DRP. But then there are two categories of numbers, RPOs and RTOs. Let's go into those on the next slide. And then there's, you don't have to define responsibilities in a DRP. There is no set in stone, sort of like a DRP document that you're going to do every time. So it's policy and somewhat tech. So every system or company, they sort of make their own kind of DRP if they do it. So let's look at the numbers. In general, there's two numbers or two categories of numbers. The RPO and the RTO. So the recovery point objective looks into the past. So how many minutes or hours or days of data is allowed to be lost if the system goes haywire or a site is destroyed or a virus wipes everything. So how good are your backups, basically, somewhat. And the RTO looks into the future, the recovery time objective looks into the future. How long is it allowed to take to get a system back up and running? And these are categories instead of like just one number. So if your container goes haywire, it's much quicker probably to fix it and get it up and running than if your whole database goes down. So when making the DRP, the plan for the first time, they're mostly just guesses, like it's probably going to take this time to, especially the RTO. With the RPO, you probably have a bit more of a good idea. But a simulation helps in tuning these numbers. So if you're familiar with high availability, if you take the RPO and the RTO and bring it as close to zero as possible, then you have a high availability system. And it's the same sort of like game of nines and zeros here. The more you pay, the more closer you get to the zero. It's quite related, maybe even the same thing in some sense. And here we have a scale. So on the left you have a long RPO or RTO, and on the right you have the zero, and which is basically a highly available system. So now that you have a plan, you want to test it out, and what I'm calling a simulation. So I got the plan, basically, and then I look at it, and then I'm told that, hey, you know, try to build this system from the infrastructure as a code. So for you to be able to do a simulation, you probably need an IAC system, or like it might be just a Word document with all the steps that, hey, you need to do this stuff to, you know, bring up this whole infrastructure. But that sort of, yeah, that's fine. But if somebody has a budget to make a disaster recovery simulation, they probably have an IAC already. But then you need to decide on the scale of the simulation. So what does it mean to be successful in so that whatever system works? And it might be, hey, you run the IAC code and all is green, you're good. Or it might be you run the IAC code, you populate your containers, you build a mobile application, run it on emulator, and actually use the backend system that you just brought up. You build a desktop application also, you really trained monkeys to use those systems for a week, whatever. So this is sort of like what you need to decide on. What does it mean that, yes, we succeeded in this endeavor? And then there's a question of who is going to do it. And well, I'm actually the only guy I know who's actually done these things. And regards these two systems, I did this work on. I was actually, I had some experience with those systems, and very little experience with the IACs used in those systems. but lots of experience in like infrastructure and whatever. So I had lots of general knowledge, but very little specific knowledge about the system. So perfect guy for that, to, you know, ask the stupid but sort of correct questions. And I asked a lot of stupid questions because I didn't know about anything. So I had to just like ask like, what is this? Why is this here, etc., etc. So the actual work is you take the IAC, you run it, you run into problems, you fix them, you make notes, you run it again. You probably have to delete all of your infrastructure a few times, etc., etc. You just go over it until you hit the agreed upon point of like, yeah, now the system works. And what you get as an outcome is, like I said, these notes, this general report, what needed to be done, how long did it take. Then you can generate suggestions for on what kind of stuff should be ready in case of that you actually need to do this. Yes?
One comment. If you accidentally delete the real production, then the simulation gets a
yes.
lot more interesting.
I think I'm going to get there also. So, and well, this is sort of like, this is what you're gonna do. This is sort of like what you're gonna get. The second one, the suggestions, is sort of like what you come up with. And then you can also do like a step-by-step on what I think about what you need to do in a real disaster recovery situation. So these could be outcomes from a simulation. So I did those simulations, and here are sort of like my general findings. There's only 2 general findings. There are things that should be parameters that are hard-coded. So both times I was told, oh, there's this one config file in the IAC. Just change those values and you're good to go. And no. If a system has a budget, enough of a budget so that you do disaster recovery simulation for it, it's going to be so complex, and there's going to be, you know, leftover bits and pieces, some IP address somewhere or some wrong name somewhere, etc., etc. That should be a parameter that isn't. And this is where it gets to your point. The simulation is actually probably more complex than a real situation. In a real situation, you are ground zero, but with the simulation, you probably have some other system, and you need to change names, IP addresses, etc., etc., so that you don't clash with the production. I think I screwed up one QA test, maybe, at one point.
One question.
Sure.
When you say running the infrastructure as code, are you saying that you're running it yourself manually, or you're triggering pipelines that will then deploy the infrastructure?
Depends on really what I did. I had like a clone of the infrastructure, and I just run.
So manually write like the Terraform or AWS?
Yes, yes. I mean, obviously you can do it because what the pipeline CI/CD system is doing basically the same. You could trigger it, but then these were sort of my findings that sort of like a bit, I don't know, and these are sort of like musings, and well, I don't know if there are any different, but, and this is also very obvious, that if you have a database, the same database backup is key. And like said before, backups and the time it takes to restore those. So how often you take backups is your RPO. How fast it is to restore them is your RTO, basically. If you are database driven, and who isn't? No, yeah. No. Who isn't database driven here? Okay, yeah, not many hands. And this is sort of like when we started really thinking about things, and I'm using OVH Cloud disaster, is that what we were thinking about, so that let's say a site disappears, and then you're like, well, my RTO is I want to recover in 2 hours. That's a good thing, but then there's going to be 200 other systems that want to recover in 2 hours. Are all of them going to recover in 2 hours? And this also gets into sort of like a thing that you are placing a lot of trust in your provider. Obviously, every time, even if you have an in-house system running on-prem, you are trusting. If I'm just the data owner, the dude that doesn't know anything about tech, I'm trusting the tech guys that they have fixed it, done it properly, etc., etc. And like with OVH Cloud incident, there's this quote that some services were backed up to machines on the same site, which like, what the hell, man? Very basic mistake. And why does it say random article quote? This thing happened 2 years ago, and the official story is not out yet. And this is sort of like, I think, my deepest finding here. If this was a plane accident, 200 people died, it would have been a black box, investigation, 4 months, report out what happened. And this has been now 2 years. Nobody knows really. That's why it's a random article quote, because the official story isn't out. I've read that it's a multinational company, national legislations in many countries. I think OVH Cloud is Canadian, and site is in Germany. There's customers, the customers, insurance companies, and the insurance companies of OVH Cloud. So it's apparently stuck in legalese. So this is sort of like we are still in baby shoes with disaster recovery in that sense, because it doesn't happen often, and when it happens, we don't really know what to do. So, I don't know about this slide at all. It sort of sucks. But if you own, this is sort of like, not so technical, but when you own the data and you do the decisions on it, you are doing the policy on what to do, but you might be dependent on policy of higher-ups, of whatever inside your company, etc., etc. These are not usually systems that are sort of like done by small organizations either, if you do a disaster recovery simulation. So it's sort of like this also affects on, like when doing a plan or the simulation on, you run into a thing and then you suddenly have to like peel the layers of what should be done here now and how long will that take, etc., etc. In a simulation, it can be really, really slow because of things like this. In a real situation, it's pretty, oh, we don't care, just get it up. And the plan itself should be seen as a continuously improved document. So your application changes, your user base changes, infrastructure might change, etc., etc. And simulation, well, it should be rerun periodically. This has been sort of like also what I'm talking with my customers is that, yeah, they want to redo it. So the actual infrastructure as a code is a complex thing. It can be really complex. It can be sort of like if you work with CDP, it can be sort of like, I don't even know what the fucking meta templating system that is that generates some other meta templating system that is run by a third system, and lots of magic happens. And so you most probably, if you are doing these kind of things, you need help from the dev team, and it's a good idea to talk with the team at that point that, hey, I actually want to have this guy 2 hours a week or something. Then this is sort of like this sort of relates to the OVH Cloud incident a little bit. Sort of like, I don't know what to name it. I called it stretching the DRP, the plan, because what if you want to recover to another cloud? Usually when you have a plan, it's sort of like, okay, if this is gone, we do it there with the same provider, etc., etc. So there's lots of stuff. I worked with many different kind of systems. I have no idea how Aurora MySQL does anything. Like, it's just read the documentation and then you're just guessing that what is going on behind those sort of doors. I don't even know if you take an Aurora MySQL dump, is it readable? I haven't checked. I should, but I haven't. So there's lots of trusting that the tech just works. Okay, any more questions?
Sure.
Yeah, so how long, in your experience, how long did it take to recover from point 0 to point 7, let's say, in your experience? Like, few hours to, it depends upon data, of course, like how much data you have and how much you want to lose.
Yeah, like doing the simulation doesn't it doesn't reflect the real situation at all.
Yeah.
It takes weeks and months to do the actual simulation if the whole organization is not with you. So sort of like you run a bit of code, then you run into, oh, we actually need this kind of DNS upgrade, and we are talking about big organizations. So what do? You talk to the manager of your customer, and they make an order, and then it goes there, and then it takes a week for the DNS, and then you rerun your IAC again, and then it's like, oh, another week to wait for the process to go forward. So, yeah.
So, how big were these two projects where you had the opportunity to do the simulation and actually figure out what are the problems with the plan and the IAC? Roughly.
I'm going with tens to hundreds of thousands lines of code, both. So these are not like I said, like if you make a disaster recovery plan at all, you're going to have a big project already. It's a big system, and then if you do a simulation, that's sort of like even more budget.
Size in man days that you had to spend to actually go through the simulation and figure out what to fix. So as an idea to organizations who have not done this and are thinking about, hey, Mr. Bossman with the money, I have this idea, what if we actually take risks seriously and try this out?
Yeah, that depends on what's the target. Like, what does it mean that the system works? And that also depends on how much documentation does the customer want. So I'm saying anything from like, if all goes well and it's a small system and there's no like horrible process to get things done, that's going to be like 10, 20 hours. And then you can just go up from there. I mean, one man day, this could be done in one man day. I've been drunk off my wits, being called that the fucking DC is down, electricity gone, get here. I'm like, I'm drunk. I don't care, come here. And we go in, 4 hours later, everything is up. Without no disaster recovery plan. So it's like when you need to do it, you just do it. But it really depends on what kind of scale the customer wants for the project. It can be really quick.
Yeah, now all the public cloud provide this replication and all those, so probably in that sense it's pretty easy. But of course, again, depends upon application basis. But if you are running some stately application in one region or one site, then putting up in other side is like just in minutes.
One thing that I had at one point was talk a little bit about integrations, but they don't really, they're not your problem. If they're down, they're down. What can you do? So, but if you have a multi-site system and your connection isn't working, then that's obviously a problem.
And again, when it comes to disaster, I think all the development should be like put together somehow. I don't know how, but it's not a single person job to decide.
No, it isn't. No.
And when it comes to disaster, so
Yeah.
everybody should be like responsible. I mean, and put it.
Yeah, that's why you have the responsibility in the document. Please.
Are you aware of any customer or other company that has a disaster recovery plan for another cloud provider? So say you are AWS, you're cloud native, you're full blown in it.
Not aware. No, I'm pretty sure there are, but not aware. Yes.
Yeah, my question was exactly that. Is there any customers who are preparing to restore another cloud?
These are things that are easy to talk about and hard to implement. But yes, yeah.
Like if you think about it, if there is a customer who's preparing for that kind of situation, then it's probably already using some of the major cloud providers who has a huge amount of regions that you can move to another region. And if that's not possible, that means that the whole Europe is down and it's not your problem anymore because the world is not working anymore.
Yes.
Actually, I can argument that. So we are aware that the war is ongoing, and Sanoma Media Finland has Helsinki Sanoma, the news media. So we are looking into figuring out if they cut the internet cable, how can in Finland we could still broadcast some sort of way news or a website that people could gain access to. But we haven't figured it out.
Isn't Nixu working on something like that?
I'm not sure if they are. I know that we are in talks with the telecom providers.
Pretty sure Nixu does stuff just like that. Yes, please.
One comment. The RPO and RTOs are quite interesting. If you ask business, it has to be zero.
Yes.
And then when you tell them that, well, we can do it, but it will cost like $100 billion.
Yes.
Can't you do it cheaper? No.
No. Yes. Yeah, it's a game of nines and zeros.
Yeah.
But nowadays, how common is it, like having this kind of plan? Is it, of course, you are recommending for every customers, but is it? Are they really taking it seriously, or
it's quite like if you Google for it, there's sort of like AWS, Amazon has their own sort of like, we have like this disaster recovery something. I don't know. They're sort of making disaster recovery as a service thing.
Oh, okay. So basically, customers are relying on them basically. Something.
But I think that's sort of like what cloud computing is in a sense. It's sort of like you get free disaster recovery readiness, free as in beer free. You know.
And it comes then a little bit difficult when you have on cloud or private cloud.
Yeah.
I'd say disaster recovery readiness is a bit dependent on the business you're in.
Yes.
Certain business areas strive or have quite strict internal requirements on that, and then it's either like, we can do it. We can get this up and running without having any plans.
I don't know if there's sort of like regulation, legislation or audit about disaster recovery readiness, because it's really tied to high availability. I don't know if they're even the same, sort of, but sort of not. You can be super highly available, but if you don't do your fucking backups, what are you doing? You're highly available and then you're dead. Yes, please.
One question about the simulations. Do you do them like after the workload is like deployed, or do you do it before based on the infrastructure as code?
I've done both.
So, because if you do after and then you said
you
need to do some changes, is it easy to make those changes?
That's why you need to rerun the simulation every now and then.
Okay, so it's a process that is continuing.
Yes. It's not like a one-off and you're done. Because it's like 1 week after you've done it, there might be a major change in whatever. That's sort of like if you're the data owner, you are stuck. You are doing your own policy, but then somebody else might come in and say, hey, actually there's now this policy. And then your sort of like old simulation is out the window. regards that part, at least. You might need to do technical changes or whatever changes to the system, and then your simulation is a bit void in that sense. Anything else? Oh, yeah. 1.5 minutes, 90 seconds for questions. If we're done, thank you.
Actually, because we are a bit ahead of schedule, so 15-minute break, so let's continue 25 past with the next 2 presentations. All right, everybody, please have a seat. We'll continue. Did you hear it there? No?
Hello. Do we hear each other in the other room? Mikko, can you check if we can hear in the other room? Can you hear in the other room? Checking 1 2 1 2. Is the sound of the police? Can you hear in the other room? Okay. So there's no. This is on green.
Yes, this is right. Yeah, that's right.
But for some reason we cannot hear in the other room.
It's the other mic.
No. It's not about that. I think it's something about system at large.
So do we need a disaster recovery?
We need a media relations disaster. Now it's okay. Fine. I'll start.
Okay, just a moment, because I guess people can hear also me, even though I'm the microphone, because we have the microphone in the roof. Just to mention that one thing that I realized just a moment ago when we started, that there was also one more reason to celebrate here, which was that the group was just getting 10 years old. So the very first meetup was held January 30th of 2013, so 10 years. And for the next break, so we have exceptionally 2 talks. So first of all, we have here Tuomas Leppilampi talking about developer experience. And then if we have, you are there, thank you, Magdalena Stenius giving the next talk. So we have these 2 in a sequence without break in between. Thank you.
Thanks, Timo. Can you guys close the door, please? Thank you. And very nice to be here. Tuomas Leppilampi is the name, and developer experience improvement is the game. So some words about me. It seems like a lifetime in IT. It was back in early 2000 when I started these things, and my primary goal is everything around future of software development. I'm not very technical myself. I used to be more technical, but then I realized that I'm better at waving hands and talking words. And I have all these lovely guys, there's some colleagues of mine there, who I work with, and I gladly give all the technical stuff to them because they're way better than me. And we work together. I like proactive teams where people take initiative, but also with the quiet Tunker types, people who like to just go into their lair and tunk the Jenkins. And yes, sir.
So that was the best photo you could find, or?
Yeah, I mean, it's kind of like me thinking, which is rare because I'm sure talking. So I usually work with always the idea of the customer, user, actor, whoever is using the stuff that we are building. I'm also in steering groups of some Business Finland projects and running some Business Finland projects on the network side, 5G, 6G. So we just today started an ominously named, come on Mika, ominously named Sunset 6G project. And I'm not sure why it's Sunset. It's about security in 6G. It's a very interesting world in the future where you have distributed security in 6G networks. The architecture is not there yet, so don't ask me anything about that. But I do a bunch of stuff. We as Eficode help a lot of companies. Some of our customers are here. We don't need new customers. We have plenty. We just need to go deeper into what they do. So some of the things that I'm going to talk about. So what are the trends? Some thoughts about software development today. And then understanding what is developer experience, why do we talk about it, and what does it mean? And you probably have heard about development/developer platforms, IDPs, and it's really kind of, we're thinking about those in terms of developer experience, cognitive overload, and all these kind of things. So we're gonna have a little talk about those, and then steering metrics. How do we know if we're going to the right direction? We're improving stuff, but what are the KPIs? What are the direction signs that will tell us if we are moving to the right road? So a lot of people say, I want to create new features. I don't care about upgrading Jenkins plugins or stuff like that. Problem is that your pipelines will fail. Your pipelines will crash unless you tunk the Jenkins. And tunking is a verb that I don't know if we came up with it in Eficode, but it's a very actively used verb of tunking stuff. Some people love to tunk, and some people love to code. And some people love to do two things, like my friend Adrian there. He's a cloud architect, but also likes to code, but also likes to look at IAC and the pipelines and YAMLs and stuff like that. Very weird species. So, software development today. CNCF landscape, cloud native landscape today. Only a part of it, to be honest. So the complexity of this landscape is fascinating. These are cards. Each one of these is a card. You're looking at over 1,000 cards with 3.5 million stars. So people who tunk, give them a star. I like this. I like that. So 3.5 million stars given to different kinds of technologies, tools, frameworks, whatever is there. Have a market cap of 20.5 trillion and funding of 66.9 billion US dollars. So complexity is there. We have a lot of stuff to use, and so the complexity rises in applications. So it's like a quarter of growth in apps deployed per customer across all industries. So all the time we are just creating new applications, and the complexity of the user world is getting higher and higher. In government sector, you do your taxes, you do your post, you do your whatever, 140% growth in the last 4 years according to Wolt. More complexity. So kudos to all of you. Creating modern software is extremely demanding. And these sources, whatever you have here, Cloud Zero, Red Hat, IBM, so to say, 256 SaaS apps used on average by companies. 256, that's madness. And usually, most of those aren't even used. I think it's like 40% of all these SaaSes and the tools that we're actually using. People have it's a rat race. It's really difficult to find. I'm trying to hire DevOps engineers all the time. I actually stopped being a team lead. I'm so desperate. Like, it's very hard to find people to do DevOps stuff for you and tunk the Jenkins. And 55% of companies have delayed rollouts due to security, and 3 out of 5 companies really even know how much they spend in cloud. So we have our work cut out for us. So, with all this, we have lost sight of the human. So it's really about the innovators and the people who actually were hired to code, to create new features, and to do that kind of handiwork that creates the innovations that we use. We somehow lost sight of the human in that.
Doesn't ChatGPT fix everything?
No, ChatGPT is banned. Thanks for asking. So like Stack Overflow banned ChatGPT a few months ago. So it's so we cannot have ChatGPT generated text. I mean, everybody's looked at those Bing AI memes, But I have also looked at quite a few videos where people very successfully create Docker files and different things, like entry-level DevOps stuff is very easy to generate with ChatGPT if you know what you're asking. And if you don't know, just watch a few YouTube videos, update your LinkedIn. There you go. You have a job. So then we have GitHub Copilot. I think everyone here has heard about that. It's just basically a glorified. It's a great tool. It's a great tool. Not a glorified autocomplete by any means. It's funny. It's like they gave 95 developers, split them randomly into groups, gave them a task of writing a web server in JavaScript. Half of them used Copilot, half of them didn't. Half the time, half the quality, and double the feeling that I was great. So that's the problem here. It's like you do it faster, you do not such a good job, and you feel like a king. I think it's an interesting. Yeah.
Isn't that the idea of Ruby on Rails and other scaffolding frameworks?
Scaffolding frameworks, yeah. You create a nice scaffold, and then you're in the top, and like whoa.
But using Copilot, you have more time to fix all the problems.
As long as you know that they're there, because when you write code, I think you think very clearly about, very accurately about what you want to do there, and you understand everything most unless you go to Stack Overflow and copy paste stuff. But when you use the glorified autocomplete, then you don't always know what's going on. This is my thinking. I don't know, but this is my thinking. Anyway, we're just undergoing a major transition in how we use help. And then we have test-driven development, which I think is going to be very important in the future, because we usually do tests as an afterthought, like, oh yeah, I just wrote some tests for the stuff that I earlier coded, and then everything passes. But it really forces you to think behind the business process. It's funny, I've been working a lot in legacy, and I've been working a lot with big banks and stuff like that. There are usually these teams of manual testers. And these manual testers often are the people who actually know what the system should be doing. So I'm always proposing these days, don't call them manual testers. It has a kind of ancient clang to it. Call them business analysts, because they actually know what the business process should be. So in that sense, writing tests is a great way to think about the business process. So I think it's going to be more and more important going in the future. Also, we increasingly ask engines to create code for our tests. And the key skills that I grew up with in QA was knowing what's the best ways to use our very limited resources for testing, and how the product is used in operational value streams. So operational value stream goes up here, the stream that makes you the money, and then you have the development value streams that feed into the operational value stream. And usually, as one part of the one point of the development value stream, you really have no idea what the operational value stream is doing. You don't know how the company is making money and how you're getting paid. But if you find out, and if you can write business process tests, you are closer to that valuable information. So those are the things that I think are very important in today's software development. And now, for developer experience, I've heard it called DX, DevX, DevX. As you can see, it's still very much under transition and consideration. I think it's very much like tools that are created for developers are a bit like engineers creating for engineers. And they usually look like something like the Lancia Orca dashboard from the 80s. It's like, this should be cool. And then you're driving and you're like, what? Look at this. What? So so we need simple things. We need simple things and a happy experience. Much simpler.
Is this a real steering wheel?
It is. It is Lancia Orca from 87 or something. No, unfortunately not. As like you would think Jenkins is a joke, but no. Our CTO, Marco, someone I highly look up to, he said, single most important part of retaining talent and maintaining continuous improvement is developer experience. So some things that create confusion and worry for us is if somebody is this kind of, you started as a developer in a new company and you created something and then you commit and then somebody comes to you, a lead developer comes to you and just like and walks away and you're like, what happened? And there are expectations that nobody really told you, nobody documented. You just know. Oh, when you've been here a few months, you'll realize why. Like I went to a company and they have like 60 different services that create three products that all work together. And we were updating the Artifactory for them, and we thought, oh, but you have these microservices, so we'll do one service at a time, and we'll just push it to you. Then the not even the lead architect, but one of the lead developers was like, stop everything right now. Why? No, we cannot touch. Like we have to do everything as a big bang. And even the chief architect was surprised. Like, I thought these were microservices. Yes, but they have dependencies. Like, God. So we don't always see the architecture, and they usually come up with when some DevOps consultant is trying to kind of push a button, and then somebody, jumps on the way. So unspoken rules and expectations really are a killer. Also, being measured by a scale you don't have influence over. So somebody's like, oh, we're going to measure you by your lead time. And then there are like 3 different approval boards and a lot of throwing things over the fence kind of thing. And you, as one little team there, have your KPIs and incentives tied to the lead time. Not fair, not nice. And also, the complexity, uncertainty of what's going to happen when I change the software. You push commit, we have a pipeline, we have all the tests, but you have this nagging feeling, like, oh, something bad's going to happen. And most often it does. So to be 3 things that we really don't like. So improving things is reduction of cognitive overload. So again, going back to this Jenkins plugins and stuff like that. And especially these days, Kubernetes, everybody loves it, everybody hates it. Because when we go to Kubernetes, we never know, it's like a box of chocolates. You never know what you're going to get. Because people have done so many things with it. You just cannot believe how many things you can do with it. And if that's abstracted down... Huh?
Sounds like Jenkins.
Yeah, it's like the future Jenkins.
I don't like this analogy.
Yeah. So sense of ownership and independence. Feature teams are a nice thought, but very often they are not reality. You cannot build feature teams. You cannot build a team that end-to-end delivers a feature. There's so many moving parts. There's so many things that change. So the sense of ownership and independence, somehow, it's a very difficult thing, but we have to strive. That has to be a North Star for us. And the responsibility over everything we deliver. I heard, no disrespect to the guy who was talking before me, but I heard many times, it's not our problem. Ooh, how I shudder when I hear it's not our problem. I think everything should more or less be everyone's problem. Like everyone should have feeling of responsibility. So self-serving instead of ticket ops. So very often people say, yes, we have DevOps, we have a DevOps team. And then you send a ticket to the DevOps team. And when they have time, they will answer you. So I do not think that's DevOps, that's ticket ops.
What about if the ticket is automatically provisioned? Is that DevOps?
Well, I think if you send out a ticket and it automatically provisions you with an environment.
So no human is doing it.
I think that's DevOps, yeah, for sure.
So we have DevOps.
Yes, congratulations. Yeah.
No, seriously.
I don't know. I think that is fine.
That is self-serving.
When you need to file a ticket to fix this DevOps ticket ops.
Yeah. I think that's Inception. You see in the movie. Yeah, you don't know what's coming first.
You use DevOps to fix the DevOps.
Yeah. That's the center of excellence.
Thanks.
Now you have new terms. So, extension towards capabilities of subject matter related to organization mission. We go back to the business processes. We have to understand what do we do, and we need to extend our capabilities towards that instead of the infrastructure and the kind of scaffolding and the structures that support our organization mission. So, also very good top tips: how to frustrate everyone and call yourself a manager. Demand teams to be responsible for running their software, and then hide ops behind a wall, a contract wall. Oh, you cannot touch anything because another company is handling that, and unfortunately there's a contract. We cannot do anything. But you have to be, you run it, you build it, you run it. I heard it from a seminar. Has to be good. So very often I see this in customers, and it's usually like, oh, we always had this and it's a legacy thing. It's fine, but don't make us responsible for running our software if you don't give us the autonomy and the access rights to do it. And I hear also that some DevOps teams or some kind of infrastructure/platform teams also support services that they don't have SLAs for, or they don't even know that it's their responsibility. So the contract wall is a real problem, and we should learn how to make better contracts. Also, don't tell dev teams, don't have any good information about Confluence or hide it very deep into Confluence. But what tools and platforms are available? There's a lot of cloud strategies and IT strategies and everything, but it's really difficult to find them. But then be sure to scold them for using their own solutions and creating shadow IT. Because very few times I can see good documentation and instructions about using the solutions that the company offers. And I don't mean good documentation, I don't mean a huge Word document that explains everything that the system does in an administrative way, but actual videos, 35-second to 3-minute videos of use case 1, use case 2, how to create a new service on an Amazon EKS cluster, how to do this, how to do that. Not a huge Word document where you have to know that it's in section 6.1, paragraph B, what you're actually searching for. Short videos. And restrict team from making decisions and about the development and delivery. Great tip is to form approval boards of managers with Toblerone calendars. Toblerone calendars are like when there's a meeting after every other meeting. And then you have to somehow find time from them to approve the technical decision you are going to make. Oh God, if I would get a piece of Toblerone for every time I see these kind of approval boards. So, actual tips. Make the boring but crucial stuff understandable. Like, why do we do IT compliance, security regulations? Especially now going to the future, we have complexity, microservices and all that. Distributed security. How do we deal with security on each one of the nodes that we are deploying? Not like how to deal with the security in an overall level, but really in reality. Like any IT compliance in general. I think it's very important to tell people why we govern stuff. Define the ways of working best practices without tool names. Don't say use this, or like in Amazon we do this, or in Google we do that, or whatever. But rather best practices about why we are doing things and what kind of benefit does it bring us. So when we do that, we're smart people. We can find a way to do that with the tools that we use. So tool-specific ways of working and best practices, I think, always restrict the thinking in the instructions. Oh, but I don't use this, it's not for me. If I don't use that specific tool, I'm not going to read that document. Standardize basic tasks, like how to configure your components, how to run tests, how to start and stop the application locally or the component locally, how to document. Create very simple ways and standardized ways of running these basic tasks, because we have so many components in our solutions that it will minimize the time and hassle for each one of these if you always have to figure out how do I start and stop this particular component. Simplify that. Continuously scan for limitations. Keep the community talking. Create communities of practice and these kind of things. And ask always, what is keeping us from improving?
Question.
Yes, sir.
Can you jump back? So you say they're making boring but crucial stuff understandable. What methodologies, systematic methodologies have you seen work within companies to make this happen?
Like for an example, for IT compliance, to really link the reasons why we cannot use a certain tool or certain way of working in our company specific. Because we have, in our strategy, we have decided to avoid a certain kind of technology or certain kind of tool or way of working and link it to some real case use case scenario. So really the kind of nasty stuff that a lot of people are asking, why can't we just deploy ourselves? Oh, we cannot, because if they audit us, then they will realize that there's no one between me and production, and that us as a bank cannot have. Like it's somehow regulated, or there's a compliance rule for that. So linking the boring, nasty stuff into real life use cases.
And have you seen this work well, like in forums like Slack, like, I don't know, Reminder or Slack, or monthly meetings or town halls, or what way to communicate this effectively that it doesn't become a spam or ignored?
That's a good one. I would usually like to link this to or somehow present it in the source, like the tool that you are using, or the like as close as the user's workbench as possible. But Slack notifications is powerful, and Teams, of course. But yeah, I think those are really good questions, and I think it's a little bit case by case answer. What works because in some companies I see Confluence works really well, and in some companies I see Confluence as a never-ending void of just stuff. So yeah, for us, for example, it's Slack. In our company, everything is in Slack. I try to move people to Confluence, but they always tell me, oh, it doesn't work for us. And of course it will not work for us if we don't start doing it, but it is a little bit case by case, unfortunately.
And one more?
Yes, sure.
I can hand it over.
Yeah. So basically it's all about knowledge sharing. So what you try to, sometimes like you write like this much text and people don't read it.
Exactly.
So it's sometimes like it makes it easier if you just have a meeting and tell them that this is not.
I'm a huge believer for videos.
Yeah,
short videos.
Or short videos or whatever. So sometimes it's much easier that way. But
and also these short videos and mentoring. That you assign a mentor to someone who will then explain, oh, we cannot do this, or you can have one mentor for 5 people. And they will explain why in our company, in this situation, we cannot do that. How am I doing with time? Good.
One more question. Relative to the standardization of the basic tasks.
Yeah.
If you have a very big organization, you can get very micro ownership of certain tasks or ways of doing things. What is your experience on bridging the gap in standardization when you have this very strong ownership, if you have any?
The strong ownership, as you mean, this is our component, we will do it the way we want.
This is how we do it and will not change because of
Exactly, yeah. So again, going back to the kind of understanding the business process and understanding the modularity and dynamic nature of things, we create this, hopefully everyone could start with that. How do we make it so generic that everybody would like to? So I think customizing and going into this kind of pet versus cattle thing. So if you think that your components are pets that you scrub until they are perfect, I think that's a wrong direction. And I think the cattle, like, it's more like, okay, we just make it no frills, as generic as possible, and encourage that kind of thinking, that people don't rub their components into perfection, and this creates this kind of strong ownership.
Yeah, I have one question. Sure. So if you have a large developer team, for example, you have like 200 developers, how do you communicate with them? Like, what do you think the best way to communicate? I mean, you can of course put everything in the Confluence, But developers are probably very busy. They wouldn't have time to, or they wouldn't have the interest to look at it. Yeah. And how do you raise their awareness on this best practice and
I would say. Sorry. Somebody said something. Anyway, I'm quite a firm believer of this kind of developer portals, so that you use one portal to access all the different tools, and then in that portal you would have kind of instructions and best practices on how to use these different tools. Alas, a lot of people don't do that. They just open Jenkins and they just open AWS portal or whatever, and you cannot, of course, create any documentation there. So then you have to go with back into kind of creating these mentoring circles and going kind of like finding those lead. 200 people in an organization, you have to have some kind of teams, right? And then doing a lot of side-by-side development, so that you sit next to someone who is more experienced, having it very personal, sharing the information in a personal way, and communities of practice, if you somehow manage to make them work. Damn, it's hard, because people think it's like additional work.
Yes, it's always like that.
Can I ask you a question? Yes. What do you think about this Spotify Backstage project?
Yeah, I like it a lot. I think there should be a kind of a software asset catalog where we can look at what do we actually have, what is the status of each one of our components, APIs and front ends and documentation, everything. It's a beautiful thing. I mean, a lot of people are doing.
Do you practice on actually deploying that?
Yeah, we do it a lot at the moment for different companies. I think it's a, so to say, hot shit. So again, we're going forwards.
Yeah, you have lots of material left.
No, I have just a few things. So I'm going to speed up and let's ask questions after. Okay. So IDPs, what's the fuss about? So what Kelsey Hightower said in 2017, he's convinced that the majority of people managing infra just want a platform as a service, and the requirement is that it has to be built by them. So we cannot go and in a consultancy company, it's like, I'm going to build your IDP, and then you use half a year and you build something, and then you just go, okay, this is yours. Has to be a collaboration with the company that you're building it with. They need to own it. They need to know how it works. They need to have the access rights and the understanding of setting up Backstage or Argo CD or whatever. So this was already in 2017, and now we are 5 years later, and only now I see it as a trend. So what is it? Curated set of tools, capabilities, processes, package for easy consumption. Zalando has a great one. Check out Henning Jacob's talks on YouTube. They have a cloud-native environment that is very, very interesting. So frictionless self-service experience. And so Gartner also paints a picture. Most enterprises will fail to scale DevOps if shared self-service platform approaches are not adopted. They will just keep on creating DevOps centers of excellence, DevOps teams, all these anti-patterns that we can see. Okay, so how to steer? How do we then know we're going to the right directions? I love it when we think about metrics by outcomes, decisions, insights, and metrics, not the other way around. Like what should we measure, but rather what should be the outcome? We should be more competitive in the digital services market. What are the decisions? Well, we should either hire more developers or we should be rethinking our architecture. And what are the insights then? Okay, hiring more developers and jamming them on a bad architecture is not going to be a good idea. You have to re-architect. And then you think about complexity and dependencies and stuff like that. So you come from the outcome and go to the metric. So how do we measure success? Of course, we do the DORA metrics, basic metrics, software delivery performance. But then Happiness of developers, operations, support, analysts, and whoever are acting in the digital services domain. Retention, we need to keep people in. We want to attract new hires. If we have an old school stack, an Oracle database, nobody wants to work with us. How quickly do we onboard people to teams? How do we nourish continuous innovation? So it's really about the quality of the customer and end user experience and the developer experience. That bullet sucks. I need to have it changed to developer experience as well. So we measure all these things as well. Some people say you can just use UX metrics to measure developer experience. Usability, findability, credibility, like trust and ease of use and all this kind of how to find different tools and things. I don't know. I think it's fine, but I suggest something novel. I suggest something new. These are not new metrics, but they are a little bit novel to DX. Work in progress. Limit the amount of work tasks that open at any given time. So limit your WIP. Scope creep. How much stuff is pushed to iterations? PO comes, you can hear the clattering of the heels. It's like, okay, so we just need to do this by Thursday. So people are not very happy about scope creep, definitely. Complexity, tight relationship between services and components, tools. So limit that, of course. Average time in meetings weekly. So time away from keyboard that is not related to developer work. Great metric. Code review lead time. You put in a pull request and say, hey, can I get some code review? And usually you wait for 3 days or something and then, looks good to me. But how frustrating is that?
Just write the bigger one.
Yeah, exactly. You still get the same result, right? Yeah. Feature ROI, the actual value that a feature brings to end users. You can start with, does anyone ever use it? Because many features out there. We push the feature. It was needed by Thursday. Nobody ever used it. So, and stretch dailies. I like this one. So the ratio of dailies that suddenly dive into solutioning and ranting. and you kind of flag a daily, say, oh, shit daily, and that will then, in the end, be a good metric. You put these together, and you have pretty good developer experience metrics, I think. People don't use these yet, but mark my words. Okay, conclusion. So, we all know that we are at the core of digital innovation today, software. So having a great developer experience is mandatory. Key competitive advantage. Show this to your manager. It is absolutely necessary. But at the same time, DevOps and platform engineering teams, we have a very hard time implementing governance policies and all these kind of satisfying audits and regulations and things like this, without sacrificing some of the autonomy, agility, and the self-service that the unique flowers who developers are deserve and want. So, that's it. Am I late?
Bit of overtime, but maybe one final question if there's any.
I have one remark about tools. There was a point about tools that they are always hidden somewhere in Confluence. I think it's not on purpose, because I think it's always a situation that there is somewhere fighter jet standing in hangar, but no one knows that it's fighter jet, and it's used by a hair dryer only.
Yes. I also think that there are great things hidden away from us, just a few coffee table discussions away. And this remote working is not helping. So this is why communities of practice, if you can get them working, please use them and then call me and explain how you got them to work, because I always fail.
One question. So we were talking about backstage self-serving development portals. For feature development teams that they're not deploying new infrastructure out of the gate, where is the benefit for them in terms of self-serving development portals?
feature teams who are not doing, they will see the status and diversity and the components and assets that other people are doing, and this catalog will give them a better view into the holistic view into the software that they're creating. Many times they look at their own thing, and that usually feeds into complexity because they architect by themselves. So this is just one aspect of it, and I think a combination of a tech radar and an asset catalog is very powerful in giving people a holistic view about the complex software that they're building. You have to.
Yeah, not a question but an action point. You said that 55% of the teams or companies are having challenges to find talent. So if you could tell me any of the companies who are not, I would be eager to hear that.
Oh, the ones that are not, yeah, let's say Apple. But yeah, thank you everyone.
Like, could you go back?
Yeah, I just want to say it. You can go there. You can go there. I don't know.
All right. Yeah. Then in the fly we switch to next speaker. No hurry, no hurry. Just take your time. Meanwhile, I made just noticed one thing what happened here today, which I've never seen happening before. I think so. I've seen the first sales guy in our meetup, so kind of now the Pandora's box is open, so whatever that means for the future, let's see.
Yeah.
Yep.
Also, a great book to read if you haven't. I just noticed it's in my bag. Mikkelsten from Project Pro. Forget projects. Yeah.
Anybody knows the local Wi-Fi here? Nobody from Nitor?
Something about engineers that was written somewhere there in the hall.
You can make it.
You can ask with the mic, they should hear it.
Where do you live?
Yeah, sure.
Okay, maybe it actually works. Maybe it works.
Digital engineer.
Digital engineer.
Yeah. What was it?
Just digital engineer.
WL and Tom. And digital
Okay,
engineer.
wait, it works.
So, you got it?
I got it. Yeah.
Okay.
Maybe you can.
I don't know. Is honest. Can someone verify that the mic is working? No? Is the mic okay? Can the other rooms hear us?
Yeah, that's a good test.
Hello? Okay. Okay, verifying the other rooms can hear us. At least okay, at least this room can hear us. It's okay? Everything works.
Yeah, everything fine.
Perfect. So this talk will be a lot more engineering heavy than the previous ones. Bear with me. If you need to top up your wine glass, go do it. And I'll be talking about a project that's very important to me personally, about measuring the carbon footprint or climate impact of deep learning models. So the agenda for this talk, I'll try to be brief. This is actually a half-hour talk. I will try to squeeze it in 20 minutes. So please ask the questions after the talk, and hopefully then we'll have some extra time to discuss. I'll start by discussing a little bit the green code scene in Finland this year and the past year. What's it about? What the discussion has been centered around. After that, I'll go into a protocol for measuring product carbon footprints called the GCP protocol. GHG protocol. Then we'll look a little bit at the carbon footprint of actual compute power And after that, we'll go into emissions for hardware production. And last but not least, I'll showcase a little example of how me and my team built a little model for estimating these carbon footprints of deep learning models. So just to give you a little bit of background into the subject, if we look at carbon footprints or greenhouse gas emissions, 1 year of emissions in Finland per capita is around a little bit above 9 tons CO2. And I think this is a little bit below the global average, which is, I believe, 11 tons. I can share the slides afterwards if you're interested in looking more at the links. An even more practical example is my old Hyundai i20 car, very rusty, from 2011. Takes about, emits about between like 100-150 grams of CO2 per kilometer driven. So this is kind of where we're starting, some everyday examples from our lives. And here are some examples then again on this kind of deep learning models. So if we look at especially language models, which are a very hot topic at the moment, training them actually emits a lot more than, for example, 1 year of living in Finland. And when we look into these like deep neural networks and transformers, both the cost of training them as well as the cost of the carbon actually have been rising significantly in the past years. Here's also an example from the MIT Technology Review about like how a large transformer model can compare to, for example, 1 year of average life in the US. And then if we look a little bit into the whole green code discussion that's been going on in Finland, maybe some of you have been following this. This was an article published in Helsingin Sanomat last year. It was about Matkahuolto and a case study about how they modernized their infrastructure and saved not only a large amount of emissions and electricity, but also I think a very significant amount of money. I think even like something in around like tens of thousands of euros per year. So by modernizing their infrastructure and actually being able to minimize the resources used, they kind of achieved a much greener system. Here's another example of a dialogue that's been going on. This news was published in Yle, and it was focusing especially on mobile networks and watching perhaps Netflix on your phone. And this article actually sparked a discussion around somehow Aalto University, based on, I think, this text, tweeted about like watching a movie on your phone can actually emit or consume as much electricity as heating up your sauna. And of course, the Finns were outraged of this comparison. And it has been one of the most persistent myths in the green code field in Finland in the past years. And many people have tried to debunk it with their own calculations on Twitter, for example, like this one. So to summarize, the discussion has been a lot centering around modernizing legacy systems, for example, case Matkahuolto, using modern solutions such as like increasing caching, using content delivery networks to kind of optimize resource kind of locations. There's also been a lot of discussion about programming languages. If you're interested in this theme, I think this talk by Emery Berger in Strangeloop last year was very interesting. So like for me as a Python engineer, I'm following the wasteful Python discussion a lot, but also inside the different programming language communities, we can see that there's a lot of focus going into optimizing the very wasteful languages, such as, for example, Python. And there has been significant optimization done, for example, between Python 3.10 and 3.11. So looking good. Then there has also been the discussion around the transfer of data. So for example, what types of connections are more or less efficient, and also does watching Netflix on your phone consume as much electricity as heating up your sauna? And the kind of overarching topic has also been just like the underutilized code, data, and infrastructure. One thing that really inspired me when I started getting into this topic was that in the podcast Koodia pinnan alla, there was someone from the Yle DevOps team. If some of you are from Yle, big fan. Hello. I heard that you were optimizing kind of some of the like dead or underutilized infrastructure resources, and also in that way saving a lot of unnecessary emissions. So that's very cool. So based on this green code discussion, a little bit into my history. So I used to work at a company called Valohai, where we were specializing in tooling for data scientists. So we are a deep learning platform with more than 100,000 machine learning models trained on our platform with different cloud resources each month. So kind of a heavy background in the MLOps field, and nowadays working at Wolt with a little bit of the same themes. So at Valohai, we wanted to kind of look into how much an example training on cloud, for example, on AWS can emit or can amount to. And luckily, well, the naive approach was just like, let's ask AWS how much they emit. So this is actually an advertisement picture from AWS when they launched their new carbon footprint tool. This was last year, and it's supposed to look like this. You know, you can see your emissions per region or per resource, and for example, your EC2 and S3 emissions should be in this view. It's under the billing console. So as I said, like quite intense, over 100,000 models trained each month. One would expect we would find something interesting here. But when we opened it, it looked like this. And then I still don't know what the reasoning behind this is, because we got no reasoning for it. One of the potential explanations why some companies saw this view when they opened the console last year was that AWS has a methodology for compensating compute in EU West 1, which happens to be one of the most used regions in Europe. And if you have a lot of infrastructure in EU West 1, it's calculated as no emissions because they compensate it. And the way they compensate it is that for the electricity used in that region, they pump out renewable electricity back into the grid, which is, it's a compensation methodology, but this is also part of the difficulty of the field. There is no rules or no actually guidelines for how you can report or how you can compensate your emissions. There's just like, decide freely for yourself.
No problem.
Yes, yeah, exactly, no emissions. Well, what we can conclude for this, and my number one tip for this evening would be like, if you use cloud resources, you can choose compensated compute. So look up which regions of your cloud provider are compensated. Google Cloud has some compensated regions. AWS has some compensated regions. If you choose those regions, that's already better than nothing. But then if we go into more of the like methodology of measuring and reporting greenhouse emissions, one of the most used protocols is called the GHG protocol, and it's dividing the emissions of a product into 3 scopes. Scope 1 being the direct emissions of like company facilities or kind of vehicles. Scope 2 being indirect emissions of the electricity used in the production phase, and then Scope 3 being the emissions that are kind of related to the product, but not directly. So for example, manufacturing of the tooling you're using for making the product. And in this article, Udit Gupta and his fellow researchers were suggesting that in the context of data centers, we could divide the emissions into these 3 scopes. So scope 1 would be the natural gas and diesel, for example, used by the actual data center. Scope 2 would be the purchased electricity, and scope 3 would be the server manufacturing that's going on behind the scenes. And in this kind of like giving estimates for carbon emissions for compute, we're going to focus on the 2 latter scopes.
Can I ask that?
No, sorry, please ask afterwards.
Okay. Yeah, where?
Yes, please. So let's first look into the scope 2, so the emissions of electricity. Some terminology that's useful in this context. The first one is called the PUE value, or the power usage effectiveness. So when we talk about the data center PUE, we talk about from all the power going into the data center, how much is going into powering the servers and how much is going into other stuff, like for example, cooling. The optimal value would of course be in this case 1, where total power is used directly by the servers and nothing is wasted. So a tip related to this is if you can choose, do use this kind of hyperscale cloud providers like AWS, GCP, because they operate at such a massive scale that they're really able to optimize the effectiveness of their data centers, which also leads to kind of less wasteful usage of electricity. And when I say like less wasteful, I mean that there is actually quite a big gap between the average data center. So here we can see the reported like average data center PUE value from a couple of years back, which was 1.7 in the US. And then again, the same year, Google reported that their PUE values were averaging at 1.12. So it actually has quite a big impact if you can choose like these kind of large-scale vendors that are able to optimize and have more modern setups. Another kind of concept that we need to look at is the carbon intensity of the region. So here you can see the carbon intensity in different areas of the world. So the lighter values are very much less carbon intense. And then when we go to darker values, then when we go to, for example, China, you can see that the kind of electricity is much more carbon heavy. So this also leads to the conclusion that if we want to make our software systems or infrastructure systems more green, we can opt for the lighter areas, and specifically the Nordics are doing very well, or Scandinavia is doing very well there at the top. So that's my tip number 3. Please choose greener regions if possible, and that kind of way you can organically like minimize the emissions by like large, like tenfold or something. So how much electricity are we using when we're training machine learning models? The first kind of naive approach is, why don't we just ask the machine? So if you're a Mac user, you can use something like stats to measure the electricity consumption at each given moment. If you're a Linux user, for example, PowerTop can do the same thing. What we want to achieve is we want to know that at a given CPU load percentage, CPU load being like the kind of most impactful indicator of electricity consumption of a computer, how much electricity is used per hour. The challenge then becomes, like, for example, if we look at AWS virtualization. So, for example, most of the EC2 instance types don't expose these types of information to the user directly. So then we can look at this existing data set collected by a team of Teeds Engineering. Basically, what their engineers did was that they, based on the fact that EC2 instances can be mapped to hardware directly. So, for example, a P3 8x large has exactly half the resources of the P3 16x large instance type. From there, you can deduct that kind of what amount of, or like how much of the virtualized hardware each of these types have as their own properties. AWS also has some types that are called bare metal types or bare metal instances that expose more of the underlying hardware. And on those instance types, you are able to run tools like, for example, Turbostat to measure the power consumption at a given time. And from running tests and load tests and measurements on those instance types, the Teeds Engineering team was then able to kind of map the consumption to these virtualized resources and then try to generalize them to other instance types. And of course, this isn't perfect, but this is a kind of guesstimation of what it probably should be. And this is the resulting data set. Everyone can access this. I'll share the slides later on. And it has listed all the AWS available instance types and the electricity consumption at various load levels. So if we then move on to the scope 3, so the emissions of manufacturing the actual servers, what is the significance of hardware manufacturing actually? Well, it has been said, guessed that it's probably the most significant contributor of server or of data center emissions. Here is an example from Finland. So this is using the Boavista hardware emissions dataset. And this is an average data center rack server in Finland with a lifetime estimation of around 3.8 or around 4 years, which is the average lifetime of a data center rack server. So you can see that the dark blue is the scope 3 emissions, and then the green one is the scope 2 or electricity consumption emissions. This chart also looks like this because this has been located in Finland, where the electricity carbon intensity is kind of very low. So if the same server were located, for example, in China, the green part would be a lot more significant. So the Boa Vista hardware dataset collects examples from different manufacturers of their servers, but if we want to look at AWS specifically, they don't use ready-made server models that are kind of available in the store. So it was very hard. It's very hard or impossible to kind of find what the emissions of manufacturing one of those could be. So the approach that Teed's engineering team took to this was that they kind of defined this minimal rack server setup with one CPU, 16 gigabytes of memory, and gave it a approximation of 1,000 kilograms of CO2 equivalent. And then on top of that, they defined some emissions for extra hardware pieces. So kind of building up of these, you could give a brief kind of estimation of a rack server manufacturing emissions. So here's an example that's very commonly used in this machine learning field. It's one of the kind of compute optimized instance types. So P4D24X large. And as I mentioned, there's the minimal rack server kind of and the base of it. And then on top of that, you would build on the data that's available on the instance type description. So looking at it has, for example, 96 virtual CPUs with the ability to thread 48 threads, so one extra CPU on top of the existing one. And then again, like going beyond like the extra memory, adding some GPUs and adding some more storage, the emissions total amounts up to like almost 5,000 kilograms of CO2 equivalent. So based on this like scope 2 and scope 3 emissions, we at Valohai built this like tiny tool, basically just that adds like a Python interface to these data sets. So it's called Watson, it's open source, anyone can use it. What you do is you give your instance type used, your region where the training was run, the hours it took, and the load percentage of the CPU. And based on that, based on these two datasets, we kind of give you an estimation of how much, or how many grams of CO2 equivalent your model took up. And here's kind of an example of the UI that you can see for each model. So you can see the region, instance type, scope 2 emissions and scope 3 emissions, and then as well as the data license, which is the Teed's engineering dataset. And then you can see whether they were compensated or not. So this was kind of like a small project that we did to kind of try to take the first steps into measuring this very complex kind of metrics from the model, and also try to encourage the data scientists to become more interested in this, and maybe also make like smarter and more green choices in their everyday work. So if we then look at what's up next, probably the trend will be that we start looking at the environmental impact beyond greenhouse gas emissions. So for example, what kind of impact the data centers have on their local community, for example, water scarcity and farmers struggling when data centers are taking up a lot of the water of the area to the cooling of the data center. Then there will also be probably a more continued development of the manufacturing emissions data sets. Hopefully, we will also see more standardized procedures for the carbon compensation, which is now the complete Wild West. And hopefully, we'll also see more an increase in like reporting the emissions of data storage. And that's all I had for tonight. As I said, my name is Magdalena. I currently work at Wolt. I just moved to Helsinki. I'm new here, so I'd be really happy to meet people and chat over coffee. And that's all for me. So now, if you have questions, go ahead, shoot. It would be nice. Yes, please.
Hey, not about the deep learning model, but thanks for this kind of insightful. I think everybody understands that they took a lot of resources, but I have a bit of this serverless architecture like running. How do you calculate for these workloads? Not if you don't have any instances.
Yeah, it's really hard because you can't possibly know what the underlying architecture of those services is.
So it's even more like naive in Square 2 kind of like calculation.
So unless like the kind of the companies whose services you are purchasing, unless they are reporting estimations.
On Amazon and like this,
Yeah.
like Fargate or like along the way, just provide you kind of some CPU.
Yeah.
Okay.
It's very hard. Hopefully they will start reporting them more. Just go into the billing console, check out what your report looks like.
Of course they pay for every minute, but can you just translate euros into the carbon emissions?
No, but you can check out if what the carbon emissions tool says. So
okay.
maybe you can find something there. Yeah.
Well, my question is a bit provocative, but
oh no.
No, it's okay. I will ask. About your slides, there was. My question is about are we the right target and are we the right audience for this? Because on your slides there was like that, China and India were like a dark red, and are the same presentations being presented in modern Chinese or Hindu about the same situation, what we are hearing here?
So I guess this depends on. So you're asking if it's a common situation that software companies in Finland are using compute from China and India.
No, my question is I'm saying that there was always mentioning that Nordics and Finland there is always it's okay, it's green, it's yellow, it's okay. The bad situation is China, India, it's bad situation there. When we are hearing this that we need to lowering carbon emission and doing this lowering, going more green and more green. Is it possible? Is it this does China and India here the same? Is any action is made there in those countries?
Yeah, I don't know.
Not only in Western Europe and not only in Western countries, but in those countries where there are pollution is the biggest one.
Yeah, I don't know.
Okay, thank you.
I have a comment on that and then a question. So I think any case we have to show example. I think it's up to us to show example, and this kind of research and this kind of tools gives us the possibility to consider things. And I work a lot with a certain bank in Finland that has a large machine learning organization. And basically, have you approached these kind of companies where there's 100 data scientists working, and we presented these to them?
No.
Okay, well, are you interested in?
Yes, sure.
Yes, okay, good. So I see a lot of potential.
I think if you generate kind of a visibility class, we are moving the needle in that sense. And
because we need to find the balance between the ROI of the application and the amount of.
But I think there is visibility already because a lot of data centers are going green and they're really going green. And I think a lot of people from here can confirm this, that they are going green. So my question is about those countries.
This is a quantitative kind of approach. So we can also say, okay, don't travel by whatever it is. I was thinking that Ferrix is more greener, but friends said to me, no, Ferrix is terrible. And it's okay, what? So there's a visibility. And that's also kind of it's a bit understanding about these computing costs.
Yeah, and I think very often when we think of software systems or AI systems, we don't think of them as material, as physical, having a physical impact on this world, and that's where this green code discussion feels so alien, because it's something that we kind of are not used to thinking about.
Comments and questions. So answering to the comments, it's always important even for Western countries to do it, because how many teams are actually looking into the infrastructure and saying, okay, we'll use Graviton, or we'll look at our CPU metrics and we'll see, okay, we can use smaller instances that are not based only on cost savings, but actually on a sustainability perspective. And my question to you is, you were showing there the EC2 types, and in AWS it's crazy, they're pumping out EC2 types all the time. How frequent is that list updated to keep up to date with all the new C6 and the Gs and all the other ones that are being pumped out by AWS all the time?
I don't know how frequently it's updated. It's an open source project, so probably not that frequently. But it's again a call to contribute if you are passionate about this topic. And as I mentioned, the way they built it was that they kind of calculated the estimations for the virtualized resources. So based on that, you should be able to kind of map again to the new resource types or instance types without having to run the whole load testing and measuring again. So that's the kind of beauty and simplicity of this. Yeah.
Yeah, I guess maybe the good starting point here would be that kind of to reduce the emissions, that you don't run anything in China if possible. But then on the other thing, I was surprised to see the white spots there in Ethiopia, Congo, and Namibia. But I guess those are countries where nothing is running at all, so that's why they are white.
I wouldn't know.
Or they're just using solar power, and it's enough for them because they don't consume that much electricity. So, could be.
Okay, anything more?
I listened to this pretty interesting podcast about programming languages and electricity consumption, and there was this point about that if you write in Rust, you use half as much as
Java wasn't liking what was
because it doesn't have a garbage collection or something. So, but is this something that you have looked into also, like about the programming languages?
So should
Rust is
everyone?
best, right?
At least according to this podcast, it is half the electricity. So,
Yeah. I mean, it's very much more efficient. And in the talk that I linked in the slides, they actually like talk about this kind of insane wastefulness that happened after this like low-level languages and like were developed, and then they started building languages such as, for example, Python on top of that. And there were no limits because there was no kind of need for limiting anything. We were just thinking like computers, like processing power and speed would just increase infinitely. So at that point there was this like madness going on about we don't need to think about these things because there is no limit, there is no like waste. We can just increase infinitely, and that's where we are at the point now when we are like starting to measure and starting to look back into the low-level languages with like this oh, this is so simple, or not simple. this is so efficient and clean compared to these like gigantic systems. Yeah.
Can I oppose on this? Because like nowadays, if there is a code running, there is CPU power and memory used, and there is like automatically converted to the money when you like burning on this code to run. So it is evaluated and it's trying to be like as little as possible. So I don't think that it's like no one cares about like it's big and wild.
Yeah. Nowadays the trend is looking better. But I think like if we're going to go into programming language efficiency, we need more alcohol. So let's just wrap up.
So let's have a 50-minute break and continue 5 to 8 with the last presentation today. Thank you. And of course, kind of the real carbon coders use assembly.
Rust.
Hello? Yes. All right, people, let's have a seat. It's time for the final round of day.
Muted? No, it's not muted. I guess you can hear me now. At least I can.
Yeah, probably it's also these mics are working.
Yeah, I'm hearing a slight echo of myself, so I guess we're online.
So while we are gathering up, so kind of two small things I could still mention about other events coming up. Well, first of all, I think we have an agreement about the host for March, so it will be kind of then coming up to the calendar soon. And but then again, kind of for the further meetups, April, May, maybe June. So just let me know, or Nico know, that if you have kind of suggestions on talks or hosts. So we are always keen to hear. About other events, so if you are in the test automation, tomorrow starts the Robocon online event, and there is today still 20% discount to the tickets. And 500 tickets sold, I heard. I'm part of the organizing team there. And then there's the DevOps conference is coming next month, was 22nd and 23rd, which is a free event then. So all DevOps stuff there, and so check it out. But now, hey, last speaker of the day, Ferrix, please. When you got your mic in place.
Yeah, it's so easy to use. And it's easy to test this in production, so it's, yeah, the big boys do test in production. So yes, yeah, talking a bit about cause and effect, and I guess that's sort of quantum thing that you can't really know both things, but yes, that's still the headline. So a DevOps through a measured approach. But a little bit about myself, a random kind of introduction. So I am that tall, my shoe size is about 45, I'm over 40 kilograms, I've been 20 years in the industry, half and half of doing real stuff and half and half doing hand waving. I am a founder in 3 companies. One of the companies is still surviving to this date. It's a stand-up company and buy me for a gig. So I'm a triathlete, as you can see. I'm also a scout, a comedian. I live in a house and I own a tent. So that's all about me. Then let's take what's a good time to form 3 sentences in your head? Let's say 15 seconds. So consider in those 15 seconds in your mind, what is your 3-sentence definition for DevOps? Since nobody's defined DevOps today, and we always need a working definition for things. So 15 seconds starts now. Halftime mark. Okay, and I'm sure that you came to the same conclusion as my definition. I'm not going to ask, since this is not an interactive stage, half of the people are in different rooms than me, but I'm still going to share mine. And this is also what we've defined in Sealy. So the first sentence is mine. So DevOps is about continually evolving robust service that adapts to customer needs. It starts by creating the visibility, the tools, and the ability for teams to truly care for the live product. So this apparently has been a problem before, and that's why we need DevOps. And it's not complete until you actually release changes routinely within the day and handle any interruptions of service effectively. Whatever your definition is, probably like 18 nines or something. And then even then, it is continuously evolving action of a group of human, or not a label on tools or a process. So
Azure DevOps isn't DevOps. It can be part of it, but yeah. And then to the people involved, DevOps is pride in their work and better sleep at night. And the better sleep at night is the sort of dearest thing in the definition to me, since there is the waking up before 6 to arrive at the data center at 6 when you just left at 12 o'clock, which sucks. Yes, well, I haven't visited the AWS sites, but I have actually held the future of a company on my knee, because the rails of the storage systems were not attached except for the lowest, which we were decommissioning. So yeah, that's like real life thing. And since I was asking for 3-word definitions, so I cheated a bit. So these are the most important definitions for me. So that's the 3 sentences. But I think it's still kind of good, since I was part of making it. And yeah, also the important thing is that it starts by creating the visibility. So that's, yeah, this is the pipeline bit, and then truly caring for the live system is the shit. And yes, I'll explain scientific process and engineering for you, since we have all the time in the world. So it starts with a red dot, which is you are here, and then you get your bearing of sort of where are you headed and so what. And then you start with a sort of not knowing where you go first, and then you name a goal of money and fame. Sometimes it's no mortgage. I'm headed towards that, but let's say it's money and fame for the love of it. And then you find a path between. And what makes it science? Sort of having a situational awareness of where you start, because that's where you start transforming. You can't transform from where you wasn't ever. And you can't transform from where you are supposed to be, because that's no transformation. You're there already or something. And then you measure it somehow. And that's the sort of, and I'll do it in a more a process-oriented way. So you identify the current state. This is mostly in my customer organization that they might not have current state awareness. And then naming desired outcome. This is really hard, because naming desired output is not the thing. So outcome, something you desire to happen, not the feature you desire. And then you quantify something. And then you experiment. And then you measure. And then you see that, okay, I am headed there. There's a sort of a progress bar of, no, we are getting closer, and yeah, we are getting further away from the goal. And that's the kind of thing. So instead of guessing, you do this stuff. And this model has been built into some systems we know quite well. So in military tactics, there's the ORDA loop, which is the observe, orient, decide, adapt. So that's the, if you are in a dogfight with 2 fighter jets, as you are, most of the audience at least, the one who makes decisions faster is the winner. And then Lean Startup has the build, measure, learn loop, and then Lean has the plan, do, check, act. And there's a difference with the ORDA loop, which is observe first, and then the Lean is plan first. I think it's more humble to observe before planning, but yeah, since after you started iterating, it doesn't make sense anymore. But or there's no difference. And then there's the inspect and adapt of Scrum. And then there's DevOps with the Scalex. Sorry, that one. And I hate that picture because it turns the discussion to the tools. But yeah, it's built into these things, or supposed to be. And then Then there's the leading and lagging indicators. And as I said, and as is apparent from my habitus, I am an Ironman. Barcelona 2018. I haven't lost a pound since. So there's a definitive metric how to measure completing an Ironman. That's, for me, that's one, done. Binary metric, have done it. But that's a lagging indicator. For that metric to move, you will have to have done one of those. And for me, it took 14 months of intense practice and 6 years of preparation. And then there are other leading indicators, sort of whether you are not going to make it before actually doing it. So for example, there is an approximate indicator, sort of buckets of Ben and Jerry's. This is something that predicts your success at an Ironman. There's also hours of training, which also predicts them. And the good part in sports science is that if you are using Ben and Jerry's for recovery, it's okay. So, but you can actually use the Ben and Jerry's measurement predicting like 12 months, 6 months, and sort of before the race day. If you have been training 0 hours, eating 365 buckets of Ben and Jerry's, it is very unlikely that the Ironman's completed metric is going to move to the desired. Well, okay, yeah, maybe you just desire ice cream more than an Ironman. But yeah, anyway, then success metrics for DevOps. I think this is what we are here for. So there's delivery performance. We know these pretty well, DORA metrics and such, but this is not enough. So this delivery performance, we have done something with quality, and then there needs to be something that tells us whether the product is successful or not. Then a sort of a leading indicator for delivery performance is the amount of learning that you can clock in. And then leading indicator for product success, which so happens to be the sort of the following level of maturity in this, is data-driven decisions, or let's say hypothesis-based way of working. And this metric I've used successfully with sort of measuring a team, or hopefully the team measuring itself. External bodies measuring the team might be, well, it might get nasty and someone's bonuses might be minimized by that means. But yeah, what is being used to measure a team and so forth. And then I also like to use these 4 quadrants of lagging and leading indicators. So whether we're predicting or analyzing the past results of a team, and then harmful and impractical measurements. And you can have it for all of these 4 levels. But yeah, let's dig deeper into the delivery performance. And this is, you all know these because these are the ones that the DevOps bubble loves. So lead time, deployment frequency, mean time to recover, change fail rate. And yeah, that's speed and quality, and mutually required instead of mutually exclusive. So speed creates quality and vice versa. And yeah, by the way, in the definition of DevOps, this is the DevOps is about, so it's all included in there. So deployment frequency is continuously evolving. Change fail rate is robust service. Adapting to customer needs is lead time. And okay, mean time to recover is not mentioned there, but it's like implicitly there. The limit to our genius not detected by mere mortals.
One question, how does this relate to the Finnish saying, vauhti korjaa virheet?
Yes, vauhti korjaa virheet, the Finnish saying the speed recovers the things. It works on a velodrome. So that's there are domains where it's true. But yeah, so the mere mortals won't notice your outage of 2 seconds because it it fits into the HTTP timeout, for example. And yeah, all of these are lagging indicators. So it's good to measure them, but you can't really predict anything based on this. But there is one thing that may predict delivery performance. That's the eNPS, the Employee Net Promoter Score. And of course, many things can be said about Net Promoter Score. So on a scale of 0 to 10, would you recommend working in these organizations to your friends or your enemies? Your enemies or only your friends or only your enemies? Or would none of the mentioned? And would you warn them? Are you a person that recommends anything to anybody? Are you a person who warns people of danger? Are you a person who generally wants to see the world burn, but would publish a public service announcement against working here? So yeah, the scale is kind of all over the place. So it's not a perfect metric. But anyway, you can say that change in real-life employee satisfaction that can be somewhat approximated with eNPS will predict your delivery performance, whether it improves, remains, or plummets. If everybody is fucking leaving, your delivery performance is going to go down because there's no one to deliver anything. And if people are happy, yeah, like the eggs of the happy programmer. But yeah, going further, product success. So we have now established that there's quality and speed. So we've done something with great speed and quality. And then there's the, well, what is it? Kind of important. So I call it product success. So yeah, it could be NPS and it has the same features. So on a scale of 0 to 10, would you recommend this to your friends? Or on a scale of 0 to 1, would you rather pay the competitor premium for this service? So that's one. Then there's revenue. Is the service producing money? Which means, are we going to have jobs in the future? Kind of important. If you put it in that way, programmers will be somewhat interested in revenue. And then KPIs, so all the corporate mumbo jumbo things like EBITDA and whatever. So these are actually, if you happen to be the front page of the online bank and your service is down, these metrics will actually tell something about your thing. But if you are the credit engine behind the mortgage processing thing, these are really, really hard to target efficiently. And the important bit, which is the hard bit, is that the team should be able to somehow measure that, okay, it's a mortgage service. How many people have actually successfully applied for a mortgage through our service? And so it means that the product success metrics have to be really, really intricately linked to what the product is. It is different for a flower shop and a hardware store. These two metrics, they should be a handful of product-specific, actionable, permanent leading indicators. So about 5-4 things, not a lot, but that you can sort of use them in the long run. And then I hope those are like that. It's really hard to get them right, so there's the hoping. And then there's these other two things which should be dynamic, currently relevant, goal-oriented, customer-focused set of team-owned self-assigned metrics. So this sort of assumes that the team has a self-service data platform where they can introduce their metrics based on their current hypothesis. I hope. So let's dig deeper into continuous learning. And here, the metrics are harder, so I'll just describe the method. So there is this Orange Bank, OP, who quite publicly announced their 70-20-10 practice, which sort of is a nice way of approaching things. So 70% of the focus and time, those are different things, but I'd say more of the focus goes into serving the customer. And serving the customer means that if the net bank is down, so the bug is serving the customer. It's not about like continuous improvement. It's like it's waste that happened and so forth. And then there's the 20% of improving daily work. And this is important about the Agile bubble talks about this continuous improvement. And it's quite important that it's continuous improvement over something. And improving daily work, in Phoenix project, they say that improving daily work is more important than the daily work itself. Yes, it sunk into you, thanks. And then there's individual growth. And this means that, for example, if there is a junior engineer in the team, well, 10% of learning the programming language that they are going to use is probably not enough, but maintaining the skills, greasing the groove and such stuff should be. So all kinds of weird prototypes and stuff like that goes into that. So improving the daily work should be something on the backlog. Well, serving the customer is on the backlog already, but individual growth is, well, unless the team is going to be learning something together, then it doesn't have to be. It might be that there's a coach who manages it for someone, or sort of coaches. And yeah, then the order of execution is reverse, so it's actually the 10, 20, 70. Because if you wonder about, if you are measuring this on a weekly scale, then consider Friday afternoon. What a great opportunity to learn something new. So, and someone is showing beer drinking motions. So yes, that's. I'm going to learn about this new IPA, not API, but yeah. Yeah. Non-existent API, IPA, yes. So, so rather start your mornings by learning something new. And by the time you open Slack on Monday morning, there will be some troubles coming your way and so forth. But of course, the production outages, someone will call you that you're not going to learn anything this day because there is a fire in the server room. And this is the continuous learning metrics, and this is what the team should somehow, using a scientific method, try to quantify.
Is this a theoretical model that you're presenting, or have you seen it actually work in specific companies?
It works in my head, in my life. So yeah. Let's say that it is for when we began teaching this thing, it was really hard to classify the things, like is a bug a serving the customer kind of thing, or is it a continuous improvement thing? So it is really hard to tell them apart. But yes, in teams who are really sort of professionals, this tends to be sort of an implicit thing.
Yeah, answer to your question, in our company we have been like developing IPA and doing it for like daily. It's a Pablo automatic self-service kiosk, and we do IPA stuff every day in hotels where you can sign into the room.
But anyways, these 10 and 20%, you don't have to do this. This is only as important as professional pride. So you don't have to have any of it, but if you have, and this goes into the split sort of the working agreement with the product owner and the team of professionals. Like, so having this stuff requires that it's like, sorry, dear PO, you're not going to have shit quality from this team. So go buy from somewhere else, please. So, and that's a hard thing for introverted programmers to do sometimes. But anyway.
As I learned years back when I was working for Tiato, there is a saying that says, laatu on paskakin laatu.
Yeah, yes. I was taught that quality is a set target level. So if you want a shitty car, Lada is probably high quality, meeting your needs. But yes, so then the data-driven decisions thing. So this is practically data science. So any kind of analytics, metrics, telemetry of what can we learn from the customer. And that requires that you have the basic pipeline stuff figured out for you. So seeing in real life, live environment that it might be an A/B test if you want the usability of Amazon product page, but anyway, sort of seeing that how does the customer interact with this? How is the performance and so forth? And of course, I think that some of this is actually like there's a lot of speak about shifting left with the quality, but of course, if you have this data-driven thing going on for you, it might be that some stuff you might actually shift right. For example, performance. If you have measured performance statistics from a live environment, what is the point of simulating the loads? So this is actually the outcome of DevOps, that you have this experimentation engine where you can interact with your customer. I'm giving an example from the hospitality industry. So as I said, I'm a triathlete, and yeah, sometimes it requires me to live in hotel rooms with my bike and with my wife. That's why there are 2 glasses, and sometimes it means champagne in Turku, because that's has been a height of the year for some time. So let's say that we have an output goal, that add a modal dialogue to the hotel reservation page that prompts for champagne. So that's a nice metric, right? Something to strive for, sort of a nice feature to add. But if you are looking back at instead of the output, you're looking at the outcome. So we want to sell more champagne. Okay, when you tell that, it appears that this adding a modal dialogue might not be the only way to do it. And so, instead of giving features, so let's see the modal dialogue again. It might be that the sales of champagne within hotel reservations is going up, because no one is reserving a hotel room anymore without champagne. But the total number of hotel reservations is going down because the damn champagne prompts you to use the competing service. So yeah, give the team business problems instead of coding tasks. That's one thing. And make solving real problems the source of engineering pride. So nobody, Tunking Jenkins, that wasn't Well, whose dream job was it? Mine, of course, but how about the others? So when you increase the amount of automation, you leave only the dream job of actually serving a real human with a real problem. And instead of celebrating what you assume that we got the feature out, it's a great success. You rather by deploying this feature in the wild, we want the 2% more champagne without actually reducing the hotel reservations in total. So prove it. And this seems to be somewhat of a problem in business life, that the sort of cause and effect get lost. So here's the little framework I've cooked up for measuring stuff. And at its best, it's about the team itself wanting to see its own paw print on the world. And if you do measure it from the outside of the team, I think the team still needs some source of pride and maybe let them, let them measure the continuous learning. This is what we want to learn next. And then when you give them the power to do data-driven decisions, they might become smarter than the business representative, and then they rule the world. And yeah, the tech is ruling the world. What could go wrong? So that's a go. Thanks. And yeah, it seems that there is time for some questions. If need be.
Well, if nobody else asks, so I have the kind of maybe the final question instead of that. So in your presentation, so was there now kind of some serious takeaways, or was this just a magnificent stand-up performance?
There are takeaways. This is something that I've used as a sort of go-to thing, like when trying to troubleshoot a team or an organization. And well, what's the difference of a team? Well, yeah, cross-team things are good to see. And that, well, when you use going all the way like 90 slides ago, well, there's only like 96 slides, so it's only a, so yeah, here. So using this thing, like putting what are the metrics being used in your organization, and then trying to put them into the quadrants of, well, okay, what are the continuous learning metrics we have? That usually, well, there's tumbleweed and crickets, but nobody's really, because it's so hard to measure continuous learning, so people rather not. Well, then the delivery performance, well, yeah, they might have DORA metrics, but how about if you want some leading indicators? If you're starting to change something, leading indicators would be good if it takes a while to see change. Product success metrics, yeah, there's revenue and then there's NPS, but how does it really matter? You're only providing the login service. Yeah. So that's maybe the number of logins and maybe the number of not failed logins for a change. Yeah.
Yeah. So kind of like a follow-up question to that. If you have this like mortgage engine, kind of like a decision-making thing. So of course you have a 70% chance of like approval rating. The 70% would be happy if you're engine, and the 30% would be not happy. But come on, you what would be in that case that for the backend for APIs? What would be the kind of like a metrics you should measure to make sure that like,
of course there's the day-to-day variation. For example, if nobody's happy for a change, like if there's the
30, yeah, if that's usually the thing, then that's a thing. But how come it's 30-70 today? So something must have happened. And then there's the sort of rejection rate, success rate, which, for example, in a bank, you intend to give some mortgages to people because that's business for you. So if like no mortgages are passing, then there's probably some pricing decision to be made, for example.
Really hard question. So based on your experience, how would you suggest an organization starts the journey building the culture for measuring? I know you have done at least 2-day workshops based on these topics. I've participated in those, but how do you do it? How do you build the culture? Because what you are saying is actually extremely hard. How do you measure, how do you think what matters? It's not an easy question. We don't do it normally in our life.
Yeah, true. I think it has something to do with the usual transformation things. You first look for a success. So you name a metric and you really see something move. And then it's like, oh, we made that happen. And then the people are more committed to that. Of course, getting them to try requires that you are targeting a problem that's real to them and they feel the pain. And then when they see that, okay, the needle moved, wow, cool, then that's that. And one of the things that helps, of course, there's a language translation barrier between business and the developers. So the developers are talking about pipelines and stuff, and then the management is talking about euros. So if you can make through the metrics, you can twist the language so that having a pipeline means less lost euros. Then you can actually sell a business case to the management, and then you'll suddenly get permission to do what you want. And that's a powerful thing. There's a gong.
Do you have experience with observability cases that there was a direct correlation between engineering and the revenue? So you could directly see that the amount of quality improvements or failed tests or deployment was directly correlated with the revenue. You've never seen it like live in your experience?
Revenue is a bit harder. NPS direct correlation with the sort of main channel for sort of customer interaction. The service portal is down. That's like a clear thing. Revenue, well, let's say that when you have, for example, the mortgage decision engine thing, that does have a quite direct thing. But I think the euros wasted, euros gained thing is, well, okay, there was this industry customer who had a flashing firmware on devices. So there was the software is complete and delivered on a device to the first customer. Lead time 32 days. We did a bit of analysis and starting with sort of what's the lead time, because they for some reason didn't have that yet. But when they had, it was like, okay, surprisingly 32 days. And then we found a single action that would reduce 14 days of lead time, including a production stoppage. And that was like the factory kind of production stoppage. So it costs money to sort of switch off all the lines. So that had a kind of a sort of reducing 14 time of the lead time and not stopping the system. So yeah, I think that's a correlation with revenue.
Last one final question. How much do you see metrics used in the customers that you see? Are they looking into it, the engineering team?
Okay, I'll answer that with a joke because it's easier to laugh than cry. So it's usually like, yes, we have the data in Azure DevOps, and then the thing is that what part of the data are you utilizing, and then there's like tumbleweed and crickets. So yeah, there's like all the data is being collected, but none of it is being used. That's one, and that's the happy case, since they do have the data that they're not using. But of course, the green code approach to that is not having the data since it's not used.
Not a question, but comment. I mean, I like the word you mentioned in the last slide, takeaway. I mean, basically, give the business case instead of coding. So basically, when it comes to engineering, it tends to like you try to put your like 100% effort to make it quality and all those things. But at the end, if you spend like whole lot of things to make it like 100%, let's say, of course that 100% is like subjective. That difference.
Yeah, and that's also the bad news to engineers in terms that you will have to learn thinking in business terms and end user terms.
Yes, exactly.
And that's not an algorithm, so it's boring. But since having algorithms in your DevOps is a mistake anyway, I guess DevOps people are more easily prone to learn about the customer.
But the customer is always wrong.
Well, you're working for the wrong customer.
Except when he pays money. So if you're always wrong, then he kind of gives you money. That's
The end customer is always wrong.
Sorry,
let me rephrase.
One who pays is good one.
Yeah.
Just we and don't use ourselves.
Do you see it as a trend now that developers are, because there's so many abstraction layers in technology that, like if we look at the evolution of technology, if you were a Java developer, you had to have this deep knowledge of Java. But today we have so many abstraction layers and so many people moving from other industries into development that they don't need to have this deep knowledge. Do you see a trend that developers are having more responsibility into looking into metrics relative to business and understanding those metrics?
No. Yes, and I think the answer to I don't think the reason we have organizations is that the problems are too hard for a single person. So I think the stuff that the team has to grasp is going up, and it means that there's a wider array of things, and I wish there was overlapping skills in the teams. But that's kind of hard. So like having more diversity of skills in the team, and also having the team topology. So having the one layer up of the teams and managing the coupling and the dependencies and that stuff is more important, because the cognitive load is otherwise going to go up indefinitely.
Also, this relates to the OKR movement, which many organizations see, that you, instead of having these old KPIs stuffed into new boxes, a good organizations might actually think what actually matters to the organization business and how does it relate to our work, but usually not. So it's still a learning process for many. And I think Ferrix is on the point, on the money.
But it's fucking hard to measure throughout the organization some kind of measurement on what is this team supposed to do to get to the end goal and what is the other team supposed to do.
They should decide for themselves, no? Like this team should come up with some measurement that is kind of like connected with value, with customer value, right?
Well, yeah, that's that's the sort of good part. And of course, there's if the team doesn't come up with their own metrics, then someone will for them, and that's going to ruin their bonuses.
Exactly.
So
motivation, it will ruin their motivation if somebody comes with the metrics.
Yeah.
But it's my experience is I've got a lot of tech experience, but when it comes to the metrics, which is connected with customer value, it's incredibly hard because you deploy some service like a feature, and after that you understand that you have then need to measure this and this and this, and so it's always I find it super difficult.
But if you can name the outcome, it comes easier. And then also if you have named the outcome that we want this real life thing to happen, then the options of making that happen becomes a sort of you can actually choose from many instead of just like let's have the modal dialogue there. So that's also the enabling the engineers to have a more free rein on how to approach the problem and reach a conclusion.
Just as a comment, just because it's hard, it doesn't mean it's not a problem worth solving. And it's a mindset aspect that you do it and then measure, because once you flip the mindset, can we measure it and then build, like test-driven development and those things. Then it switches everything, and then you actually can understand if this feature provides value or doesn't provide value.
There's the Einstein quote of the problems cannot be solved from the level of thinking where they were created. So then increasing your standards is a necessity.
Yeah, okay. I think we can probably continue this offline, but continuing my Pandora's box thinking I mentioned earlier is that the one thing you probably need to do is anyway that they break the silos between engineering and sales. That's the first thing. But anyway, thanks for Ferrix once again. And based on what Pasi said in the beginning, so we are in no hurry to leave here, so sauna is hot and so forth, so if you are interested in, but thanks from my behalf, thanks for joining and see you next time.
Thank you.
Thank you. I have actually a question. I'm going to have a class this room in tomorrow morning. I could use some hand power, so if someone wants to help, I don't mind. So